Hello everyone, this is John and I'm doing my micronutrient presentation on iron, so hope you enjoy. Alright, so just to start out, this is a table from the USDA DRI tables, and it is just showing the RDA over here in the middle section, and then that section on the right is the UL. But iron is a trace mineral that we can obtain through our diet, and 1 in 4 people in the world have anemia, and a major portion of those is due to iron deficiency anemia. So just to start out, the RDA of iron is usually around 8 to 18, but it kind of depends on if you're a male or a female and what stage of life you are in. Usually when someone's growing up, going through puberty in the growth stage, then it's a little bit more. And women, girls, as they're going through their growing up stage, they go through their menstrual cycles and they lose a little bit more blood, so their RDA for iron is a little bit higher as well. And the UL for iron is about 40 to 45, generally 45 though, so 45 milligrams a day is that UL for that. So there are 2 sources of iron, or 2 types, I might say. One is heme iron, and that's found in animal products, any of the meat you eat, like chicken, beef, fish, seafood, those kind of things. And anything else, any other kind of iron, is non-heme iron, and we can find these in vegetables and spinach, kale, those dark leafy greens, and different kind of beans like lentils and kidney beans, grains, and of course supplements. You can find iron in supplements. Refined flour is actually something you can find iron in, because due to the enrichment process of enriched white and wheat flour, iron is added to refined flours, so there's another source of non-heme iron. And also, kind of gross, but anytime we cook with an iron pan or cast iron skillet, if there's a little bit of that chips off into our food, then you can add that to your daily vitamin intake. Alright, so functions of iron in the body. A lot of times we require, or we depend on the redox reactions of iron, and I actually switch those around, but the ferric iron, the Fe3 plus, will be converted to the Fe2 plus, the ferrous ion, which is the more absorbable one. We can bind both of them in storage proteins, but Fe2 is generally the more absorbable one, and Fe3 is generally what we'll find in our non-heme irons. Iron actually helps a lot in metabolism. So hemoglobin, which we'll talk about in a little bit, it has binding sites for oxygen, carbon dioxide. It helps deliver oxygen to body tissues from the lungs, as well as muscles. And as it's away, hemoglobin, it will bind carbon dioxide in the tissues, and it will bring it back to the lungs for exhalation. Aconitase, this is something that I thought was very interesting. Aconitase is an enzyme found in the mitochondria, and it assists in the citric acid cycle, which we talked about in last chapter actually, yeah. And aconitase is an enzyme that helps the substrate go from citrate to isocitrate, so it helps facilitate that substrate production. But aconitase is made up largely of iron and sulfur, actually, so I thought that was very interesting how it helped in that. Also, it helps in the electron transport chain, those lipid-bound molecules called ubiquinone and cytochrome C that help deliver electrons down the chain. Those are made up of iron as well. So as we can see, iron helps quite a bit in metabolism. Iron are also cofactors of enzymes that help synthesize brain neurotransmitters, and these include dopamine, serotonin, epinephrine, and norepinephrine, and those do some pretty important things in regard to emotion, and epinephrine and norepinephrine playing a large role in the nervous system. So without iron being cofactors for those enzymes, we wouldn't be able to have those. Also, iron helps lymphocyte production. In particular, the T lymphocytes, or you might know them as cytotoxic T cells, and they help go around and destroy foreign materials in the body. But this is one of those things that is very important to keep in mind as we are regulating our nutrition, because if we don't have enough, then we're not able to make those lymphocytes. But if we have too much iron, bacteria actually require iron to grow and to proliferate, or to divide. And so that's one of those things we got to keep in check, keep that balance. Alright, so some iron proteins. We talked a little bit about the functional proteins, but hemoglobin is a major component of our red blood cells, and it, like we said, helps transport oxygen and carbon dioxide. It has 4 different binding sites for oxygen, so it can carry a good amount of oxygen. And myoglobin is pretty similar, but myoglobin is just in the muscles, and it carries 1 oxygen molecule though. And iron-containing enzymes, we'll talk a little bit about those. Conatase is the major one. And the transport proteins, transferrin and ferroportin, these are important because as these bind to iron, it prevents, from all those redox reactions. Iron is pretty reactive, so it can actually make free radicals in the body, and those can damage cell membranes and DNA. So it's pretty important that we have these transport proteins, also to carry iron from in different parts of the body to help us make some of these different things, like a conatase and different molecules. And the storage proteins we'll talk about in a little bit, but ferritin's found in the enterocytes in the small intestine. It helps bind those iron molecules so that we can prevent those free radicals. And also hemosiderin is found in the liver, which is the main storage site of iron. Alright, iron deficiency is the most common nutritional deficiency in the U.S. The symptoms: fatigue, loss of appetite, and reduced resistance to infection, like we talked about a little bit. Those at greatest risk are women, young children, vegetarians, and those who donate blood more than 4 times a year. And so women and those who donate blood, this is because of the loss of blood through menstrual cycles, and the donation of blood, obviously. Young children, they actually, it's not much because of their diet, but a lot of times when kids are growing up, they are encouraged to drink a lot of milk, and the calcium in milk actually is something that will inhibit the absorption of iron. And vegetarians, they get a lot of non-heme iron, from those leafy greens and legumes and stuff we talked about, but they don't get the proper amount of heme iron, and some of the things in the vegetables that they eat will inhibit the absorption of iron, and we'll go to that right now. So, like I said, those whole grains and legumes, leafy greens, all those vegetables have phytic acid and oxalic acid in them, and they'll actually bind to non-heme iron and prevent its absorption. Also, polyphenols and all those things, tea, coffee, red wine, oregano, will decrease that absorption. Reduce gastric activity. So the acid in the stomach is what actually helps facilitate that, going from the ferric ion, Fe3 plus, to the ferrous ion, which helps it to be absorbed greater. And so if you have a reduced gastric activity, then that's going to inhibit that. And as we talked about a little bit, excessive intake of those minerals, zinc, magnesium, calcium, those will prevent the absorption of iron. So increase absorption, things that will help it, high body demand for red blood cells, and iron in the food. The body's pretty good at keeping homeostasis, so if it needs something, that it'll signal the production of red blood cells through erythropoietin, or it'll just start grabbing all the iron it can with those storage ions, or storage iron proteins. And heme iron in food and MPF, they actually, if you eat those things, a little bit of those things with non-heme iron, it'll increase the absorption of non-heme iron, so that's nice. And vitamin C, actually, it will donate an electron to the ferric ion, which will reduce it to the ferrous ion, so that helps that. The UL is around 40 to 45, generally 45 depending on who you are, but the UL for iron, effects can be nausea, vomiting, stomach irritation, diarrhea, impaired absorption of other minerals, and liver dysfunction. So children and adults, children are more likely to be affected by toxicity because of the little chewable vitamins that they get, because a lot of the vitamins will have a lot of iron in them, and so that will take them over the UL. Adults, genetics can play a role. There's this thing called hemochromatosis, and it affects about 1 in 500 people, so it's pretty rare. But there's this thing called hepcidin. Sorry, this thing called hepcidin, and it usually will degrade the transport protein ferroportin. And when there's higher ferroportin than normal, then there's going to be a lot more iron transported throughout the body, and nothing keeping it back. So that hepcidin is pretty important. But those adults who have hemochromatosis will have the iron toxicity risk. Alright, so what's our takeaway message? I think our takeaway message is balance. We need to have a good balance, because then we see all the things that iron can do in our body. So it helps us to keep up our lymphatic system and fight foreign materials. But if we take way too much, then all those bad side effects can happen, along with the growth of bacteria in our body. So I think balance is very important for iron. But I want to thank you guys for all listening in. Here are my references, and I'll catch you later.